Hi there, I'm Rebecca Fiebrink. I'm a professor at the Creative Computing Institute at University of the Arts London. And today I'm going to be talking about interactive machine learning as a tool for making musical instruments, embodied experiences, and interactive art. Now, of course, lots of people are talking about creative applications of machine learning right now, but many of them are asking questions that make me a little bit sad, like, are machines really capable of being creative or making real music or art? Or isn't it terrible there will be no more jobs for creative people? I think these are the wrong questions to ask. And in fact, the questions that I've been focusing on in my research for the last 20 years or so have really been around how might people use machine learning within their own existing creative practices? And how might machine learning expand people's creative capabilities? These are really questions about when and why it might be creatively useful to find patterns, make predictions, or generate new data, because this is what machine learning really is at the end of the day. Now, one way into answering these questions is to think about what types of data are useful or interesting in different types of creative practice. And when you start looking for such data, you find out that it's everywhere. And creators can benefit in many ways when they are able to work more effectively with this data. When I began this research in 2008, I was working with musicians who were interested in building new musical instruments and other performance interfaces. They were using sensors like these to capture information about how performers moved their bodies, then writing software to translate those movements into sound. Soon after, I noticed that people in other fields were tackling essentially the same type of engineering problems. A dancer might want to capture and track her movements, for example, to coordinate lighting or other effects. Or a game designer might want to use physical actions of players rather than simple button presses to control gameplay. As many of you know, devices like these on screen can make getting raw data about human actions easy. However, if you've ever tried to build an interactive interface with this data, you know that interpreting it or mapping it to meaningful control over sound or image or other processes, this can be difficult and annoying, even for people with deep expertise in programming and signal processing. Now, a lot of the systems we might want to build with data can be thought of as having some kind of mapping, where the computer sees some kind of data in the world, maybe an input to the computer, and then it makes a decision about what to do as a result, what to output. For instance, if I'm building a new musical instrument, I might want the computer to produce different sounds based on the gesture I'm performing. Or I might want the computer to listen to the sound of a human musician and then map this to control over live visuals or lighting. Or I may want to make a game that responds to a player's motions or speech, for instance, triggering different in-game actions. It turns out that all of these are a great fit for a type of machine learning called supervised learning. Supervised learning allows us to build a model or mapping function which looks at data coming in and makes a decision about what values to output. For instance, this model here could look at data from my webcam, try to decide what gesture I'm making, and then choose which sound a music program should play. Instead of having to write this function by hand as a programmer, however, we can instead use a machine learning algorithm to build this function from examples of inputs and outputs, of sensor data and musical choices. So here I could give some examples maybe of different hand positions, each one paired with the sound I want to result from that position. In 2008, I built a tool called Wekinator to allow musical instrument builders and other creators to use machine learning to build these types of mapping functions. Wekinator allows you to do a few things that are pretty unusual in more mainstream machine learning systems used outside of creative practice. First, Wekinator allows you to demonstrate these training examples in real time, showing the computer yourself what kinds of behavior you want. Second, once you've built a model function from your examples, you can try it out. For instance, move around in real time and see what kinds of sounds your instrument makes. If you like what it does, great, you can use the model in performance. But if you don't like it, Wekinator allows you to change the model function by changing the training data, by adding new examples and then retraining the algorithm on that new data. For instance, if I find that my model makes a mistake when I have my hand slightly tilted, I can just add more training examples showing the correct sound to make when my hand is tilted. Let's do some demos. All right, in this demo, I'm going to build a very simple gesture-controlled drum machine using Wekinator. As my input device to capture information about gesture, I'm going to use my webcam. And I've got a little program here which I like to call the world's worst computer vision feature extractor. What I'm doing is just taking those pixels coming in from the webcam and downsampling that to a 10 by 10
grid of color values. And this gives me 100 numbers, and these numbers are going to change as I move in front of the camera, as you see. But even if you're an amazing programmer, I would guess that you would not want the job of writing the program that looks at these 100 values and says something useful about what I am doing in front of the camera. So instead, we're going to use machine learning to make sense of these 100 values and make pretty accurate predictions about what kinds of gestures or motions I'm doing. All right, so I'm going to have Wekinator here listen to 100 values from this camera program, and I'm going to build a classifier, which is going to, again, predict what type of action am I doing at the moment. And we're not going to load a training set from somewhere else. We're actually going to build this training set right from scratch in the demo. And I want to, not just have Wekinator output a number. I want to have this control a sound and make this a little bit fun, right? We're going to control a drum machine, like I said. So I'm going to run a very simple drum machine program written in Chuck. And when I send this drum machine different numbers, we're going to hear different sounds, just like this. All right, so let's start out. Let's give it some training examples. And I'm going to say that when I am right here in front of the camera, I want to hear this simple sound. So I've got 17 snapshots of me here paired with this sound. And next I'm going to tell it that when I'm not in front of the camera, turn that down so you can hear. When I'm not in front of the camera, when I'm out of frame, I want to play a different sound, specifically this one. Let's go. Okay, now I've trained, I've built my model. Let's run this model and see what happens. Okay, it's pretty good. It's definitely changing between the two sounds, more or less the way I'd like it to. However, it's being a little bit too eager to change to that second sound, even when I'm not totally out of frame yet. So I'm going to give it some more training examples to try to fix that error and say that when I'm right here, actually I still want to hear the first sound. And now I'll retrain, I'll rebuild that model, and we'll see if it works any better. And in fact, that's pretty good. I can keep moving around and see if I can make it make other mistakes, like right here. I can, oops, forget I did that. Let's give this as sound 1 and say that I want sound 1 over here. And I can retrain and keep running and see that, yes, it's doing what I'd like. And once I'm happy with that, maybe I want to make it more complicated. I could give it another sound with, say, my hand in front of the camera, like this. Okay, there we go. That is a pretty easy way of using Wekinator to make a classifier where I'm controlling a few different sounds based on simple movements of my body. All right, so that demo I just showed you was pretty fun. You can imagine that for an audience, watching somebody move on the stage is probably more interesting than watching them just change sound by clicking a mouse button. And in the hands of a good choreographer, you can imagine something that becomes really visually compelling as well as sonically interesting. But when professional composers have used Wekinator, they're using it in a slightly different way, often to exploit the fact that you can use machine learning to build very different types of instruments. The sounds that you heard in the previous instrument were the same sounds that I could easily make by just pressing a few buttons to switch between different sound options. But sound becomes a lot more fun to many electronic composers when you can explore a really big space of sounds, when you've got a large palette to draw from and you can come up with ways of playing sound that are much more nuanced, much more complex, more exciting than just switching between a few different presets. So in this demo, I'm going to show you how you can use Wekinator with regression to do exactly that. And the instrument we're going to play is going to control a sound synthesis algorithm called Blotar. And Blotar is fun because it has a lot of different sounds that it's capable of making. So here's just a few of the Blotar sounds. Okay. And for each of these sounds, I'm getting that sound by giving Blotar a different set of control parameters. Specifically, I'm changing 9 of its control parameters. So you can think of each of those sounds as a point in a 9-dimensional space. And I'm going to build a Blotar instrument where I control these sounds using this. This is a game track controller from an old PlayStation game called Real World Golf. But we're just going to use it as essentially a 6-axis joystick. I get X, Y, and length of each of these 2 strings that I pull out of the bass here. And so I'm going to tell Wekinator I want to take these 6 input values and use them to control those 9 Blotar parameters. And I'm going to use regression so I get smooth changes. And of course, this is, again, something that would be really hard to do even for someone who's an expert programmer, because not only are you trying to find good positions in this 9-dimensional space, but you're trying to come up with a mapping function that says how the motions that somebody's doing here move you through that space in a way that's not only musically interesting, but maybe gesturally comfortable, where the gestural mapping might be easy to learn or easy to execute certain gestures that give you sonic gestures, and so on. So that's very hard to think about as a programmer. It's a complex function to write, but here we can do it pretty easily with machine learning. So I'm going to start out by finding a sound that I want to put in the Blotar. And maybe I want that sound, and I'm just going to put it over here pretty comfortably. Record some examples, and maybe another sound higher in pitch, say over here. You can record some examples here, and just training from these, you understand what's going to start happening. Okay, so I've got smooth change, and it's learned that lower pitch is over here, higher pitch is over here. That's fine, not too interesting yet. Let's start to add more sounds in and see what happens. With this sound over here. Should mention this is taking a little bit longer than usual to train because I'm running my video capture software at the same time. Okay, so hopefully you saw some interesting stuff happening there. Not only was it giving me access roughly to the sounds that I put in the training set, and still having this behavior that when my hand was kind of back here, I was getting a low to high pitch relationship, but it was also giving me all sorts of other sounds as I moved between these very, very different timbres, which I'd put in different parts of my gesture space. I was getting sounds that I didn't put in the training set that I have never heard before, even though I do this demo quite frequently. And this means that I can start gesturally exploring the space of this synthesis algorithm. And of course, I can use machine learning to refine this instrument or this mapping that I've created. If I like a sound somewhere, I say, oh, that's a really cool sound and I like it where it is. I can add more training examples of that pair to reinforce that behavior. Or if I don't like a sound somewhere, I say, oh, that's silly, that's silent, or that's just really stupid sounding. I can put a different sound in that part of the gesture space and retrain it, and I'll get a different instrument. And I can keep refining my instrument in this way until I'm happy with it. Then I can save the whole thing and run it, the models as they are during performance. Or perhaps I could even write a piece, and I've done this a few times in the past, where a performer retrains the instrument on stage, and the evolving relationship between sound and gestures is part of a piece. But most composers don't do that. Most composers spend a fair amount of time refining the instrument until it's something that they're happy with, and then they move on and do other aspects of the work.
Now, Wekinator has been used by thousands, tens of thousands of people all around the world in making creative work in music and many other domains. I want to show you some examples of this work. In all of these, machine learning is used to unlock the creative potential of data, making it easier for people to build systems that respond to human actions or the environment. The first example I'll show you is from Michelle Nagai. She built an amazing instrument called Martlet from a piece of tree bark. Here you go.
Basically taking the data and it's comparing it to examples that I've given it in the past of relationships between a certain data and a certain gesture and a certain sound. So if I train the machine learning software that when I wrap my arms around the instrument and the sensors register less light, it makes a particular kind of sound, and then full light, it makes a different kind of sound. So I give it all these examples in the training process, and then I run it and I see what happens, and it takes the data that's coming in and says, oh, that looks just like the data, or that's similar to the data that she has when she wants this sound. So it sends that message to my sound processor, and the computer outputs that sound. So it's just another way, basically, of mapping gesture to sound.
This next piece I'll show you is from Handwriting, or Wuxing, by Han Shuo Fan. In this piece, the performer's hands are measured using a leap motion sensor, and as the performer does different gestures associated with Chinese calligraphy, the sound and the visuals behind the performer change. This is an interactive art piece made with Wekinator. In this piece, you wear a camera on your head. That camera sends information about what's in your field of view to Wekinator. And there's a classifier, a model inside Wekinator that decides whether or not you're looking at a screen, whether there's a phone or television or laptop in your field of view. And if there is, it sends a message to these special glasses you're wearing and tells them to turn opaque. So this is an art piece that prevents you from looking at screens. This is an example of a demonstration of a game made by one of my students a couple years ago. This uses a tool called Interactimel, which is based on Wekinator but made for use in game engines. In this example, you'll see that the input to the machine learning model is the position of your character on the screen, and this model is controlling objects in the game environment based on where you are. So it makes a really different kind of interactive puzzle. You have to figure out how to move through the space to get the objects where you want them to be. So here you see the stairs and these cones moving around as you move. This is another game example from a student of mine, Isabella Mound. Here she made a spellcasting game. And this one, you just play with your mouse, but you can draw different patterns on screen with your mouse chosen from a spell book. And as you draw them, the computer tries to identify which spell you're casting. If you happen to cast a spell correctly and it's the right one for that moment in the game, then you can have success in moving on to the next challenge. The last example I'll show you is Highbot by Carolyn Hermans. The input to this is a leap motion sensor measuring information about where the joints of your hand are in space. Wekinator is used to determine whether you're waving or not. And if you are, it sends a message to a little motor attached to an Arduino, which is behind this little cardboard robot. There you go. Before I wrap up, I want to say a few words about how using interactive machine learning for mappings can impact on the design process, because it turns out that this approach offers a number of other benefits beyond just allowing people to work more effectively and accurately with sensor data. First, it turns out that using data and machine learning can be a lot better than math and code for communicating tacit knowledge and embodied practices to a computer. If you think about how you wave, for instance, if you were going to try to describe that to an alien who landed on Earth, you probably wouldn't describe that in words. You probably wouldn't describe that with a mathematical equation. Instead, you'd probably show some examples of waving, maybe in different styles. Turns out this is a great way to communicate to computers. It's much more natural and easy for us, and machine learning allows us to communicate this way rather than trying to change how we think about the things that we do as musicians, as dancers, as people moving and living in a space. Second, machine learning can allow creators to quickly prototype and explore many ideas. We know from research that this prototyping, exploration is key to any creative practice. And when I've studied people using Wekinator, one of the things that I've noticed is that they love to take advantage of this ability to make a thing really quickly, change that thing over and over by small changes to the training data. They can ultimately explore a much wider design space in a shorter amount of time than if they were trying to program and debug programming code. So in the end, this can allow people to end up with a system that's much more satisfying to them, that better meets their design goals. Third, designing with data enables more people to become creators. Anybody can provide examples given the right user interface. You don't need to be a programmer or a signal processing expert or even a machine learning expert to use this Wekinator style interactive machine learning to build something that's really your own. For instance, in the sound control project you see on screen, my team built interactive machine learning tools for music teachers and therapists. These enabled them to build new musical instruments for kids with a really wide variety of disabilities, even though nobody here was a programmer or a sensor expert. And finally, machine learning can open up new creative relationships between humans and machines. For instance, Letitia Tsunami is an instrument builder who's used Wekinator for many years now. I once asked her to talk about why she likes using machine learning in her work. And she says that, in a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild, and you want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring, instead of going, I have to have a result right away, this thing is going to do that, and leaving it at that. And I think this is great. This speaks to a lot of the fun of exploring and the surprise that's accessible when you use machine learning, especially with regression, to give you totally new sounds that you didn't expect, or totally new computer behaviors that you didn't expect, right? You can give a few training examples that start to sketch out the kind of output space that you're interested in, but with certain types of machine learning models, especially regression, you have the capacity for that machine to give you something new that wasn't in the data. And of course, when you just build a mapping by programming, most of the time if you're surprised, it's because there's a bug in your code and you have a compiler error or something doesn't work. But with machine learning, it can be really easy to be surprised with new sounds, with new behaviors that might actually inspire you. So that concludes my presentation. Thank you so much for listening.